Okay, let's continue for the next one. We want to test for empty relationships. So that means whether a table relationship means a table for here is empty or not. For example, use a subquery, and then the result will be a table. Whether this table is empty or not, we can use the exist construct. Okay, so this is keyword exist. For example, if we set exist R, that means this is true, means there's not non-empty table. Okay, non-empty table R. So that means R is not to an empty set. Otherwise, if we set not exist R, means the table is empty. Okay, there's no single tuple in this relation. Okay, so that means we can use this exist or not exist in front of the subquery to test that whether the subquery will return empty set or not. So that means whether it's empty or non-empty. Let's look at the example. So for this example, we do the example before. Find all courses taught in both this semester and this semester. So we in the past we use intersect. Okay, you can also use join. Okay, or just use other maybe in or something. Okay, use those things. Set membership, and here we want to use exist. Okay, use exist to do this query again. So the idea is that you first find courses offered in this semester, and then check for each of the result, check each tuple in the first list. That means all the courses offered in the fall 2017. Check each of them whether you can find a query. That means you retrieve. Okay, you can find a query which is not empty. A table is not empty, which is based on this course ID you retrieve for this year, whether it is offered as well in this new semester. So this is the basic idea. Okay? So let's look at for this semester. We do the query. That's easy. Just straightforward. Select course ID from the section, and then this one is equal to 4, this one is equal to 2017. So this semester, and then we rename it to be S. The reason is that we want to mention. We mentioned it before. We want to test the ID appeared here, but also appears in this query. So we want to refer to the section table again. We want to differentiate this as this section and this section. So we want to differentiate because this is otherwise we cannot write a condition like this way. We cannot differentiate the same name. Okay? So that's why we give a new name. So rename it to be S table, rename this one to be T table. And then we do this one is we want to find whether this course also appear in the spring 2018 semester. So similar thing is like this one. Select star from select section as T. So while we use star, we later will tell you what's the reason. From whether we need to use course ID or something. But use course ID, of course, is not wrong. But for simplicity, we use star. Means just all the tuple contents. And then similar like this one, the new semester, and the same course ID. So that means we based on the same course ID query for this year, whether it has a record. So that means the same course has also being offered in this semester. So S course ID equal to T dot course ID means this course has been offered in both fall 2017 and spring 2018. If like that, we output this result. Right? So as long as you have one tuple in this result, one tuple in this one, maybe this course is offered in multiple sections. Right? Multiple sections. As long as you can find one, so that means this course has been offered in both semesters. So that's the reason we don't care about whether it's course ID or the semester year and credit and so on. We only care about whether you can return a non-empty or empty set. If it's empty, that means this course is not offered in this semester because you cannot find any single tuple for this query. This query will return a set. If this set is empty, means this course is not offered, was not offered in this new semester. Okay? So that's why we use a star. We don't care about any specific attribute. We only care about the set is empty or not. So whether the set is empty or not, we mentioned that we use exist R. So R for here is a query, is a table. So that means whether this table is empty or not. If it's empty, means not offered. So we will not output that one because this doesn't hold, and must be all of them hold. And if it is true, then we output that course ID. Okay. To create these new tables, we create a new correlation name. Okay, just variable. So variable s in the outer query, and this is the correlated subquery. That means this course was offered in this semester and also offered this semester. So we use this condition to indicate their relationship. So this is the inner query. Right? From S, we put this S inside of the inner query to establish the relationship between this one. Okay? Between this one means the AND. Okay, this is a trick, okay? Just like this. So this is a very common framework for us to do such things. That means like an intersection. Okay, and also build a bridge between two queries via this way. Okay? You can relay. Okay, let's continue. The next one is also a very typical example. So we want to find this thing. Okay, for every, let's look at find all students who have taken all courses offered in the biology department. So this one is not an issue. Okay? The most important thing is that taken all courses offered in the biology department. So how can we find a student who have registered, who have taken all courses by one department? Okay, you can maybe think about, it's just list all the courses of the biology department. But how to compare next? You want to compare a student registered courses, that's a set, and then all the courses offered in the biology department, another set. But how can we compare two sets? Okay? Two sets. So this one seems hard. So if you want to compare two sets, we need to use an indirect way. In fact, we use a lot exist. Why we use a lot exist? Because we have a formula called this one. Okay. So the basic rule is based on a mathematical maybe rule, okay? Or it's a theory. For example, we want to compare two sets. If we have this, we can get this x minus y equal to empty. Then x is a subset of y. So you can consider this one, okay, like this. For example, x is the courses offered by biology. Y is the courses taken by a student. If all the courses for any course offered by the biology department, it belongs to Y, means the students taken courses. Then of course means this student has taken all the courses offered by the biology. Is it correct? So this is the trick, correct? So this is also like this. X is a small, X is a small set, Y is a big set. So this is X, this is Y. Okay. So for any element for here, it belongs to the Y, correct? Because as X is a subset. So if you use X minus Y, you will get empty, correct? Because there's no element which belongs to X but not belongs to Y, correct? Because as is X at least Y is at least is equal to Y. Y most probably Y is larger than X. Y is larger, correct? So Y is larger here. So at least there's some elements which is outside. Okay. So this is the idea. That means we use this way to compare the empty. Okay? Compare the empty. So here the minus we use except, and then X we use the biology department offered courses. Y we use this students taken courses. Okay. If not exist means we mentioned before. Okay, not exist means there's no single tuple in R. That's why we said R not exist. R is an empty table. So that means this one is empty. Right? This is empty, not exist. So this one is this one. So this means biology of the courses minus a student taken courses equal to empty. Then we list those students. Okay. Let's look at in detail. Select a course ID from course department equal to biology. That's easy, correct? Because that's all the courses offered by the biology. So is course, that's enough. You just use course, okay? Course ID, because you will compare the course ID, okay? Based on the course ID. ID will be differentiate a course from another course. Okay. And except is a minus. Y is the courses taken by a student. So also the course ID. But here we want to from the takes, because that shows the courses taken by a student. Takes as a new, for example, refer to a new name as ch. Easy to understand. Okay? You can also just use the text. Doesn't matter, because there's no other places we use text. Okay, and then we have a relationship s.id equal to t.id. This is just because we want to output those students. Okay, so let's look at what outer query. We want to output the student's information. So we want to put the student ID and the student's name. So distinct this tuple, okay, SID and SName. Okay. For example, maybe a student register, will appear twice. So we will only list this pair by one time. So this one can only obtained from the student, because you cannot get all the information from text. Text only have the student ID, does not have the student name. So we use this student table. Use this one, refer to S as a S. So this S and the text, how to connect them together? Use ID. Okay? ID is the primary key for both, not for both, for student. Okay? So that's the SID must equal to the text ID. Text ID means the student ID. So this one we establish the outer and the inner queries. Okay, and this one will establish the relationship between these two tables or two sets. Okay, that will meet our requirement. We just get this one. You cannot use equal, because equal to all. So in the past, we do have students write have mistakes like this way. Equal to all means it is a member equal to a set. This one is equal to all of them, but you cannot compare two sets equal to all. So we have this problem. We cannot use equal to all or anything like this. We can only use this way, just like a compare. Compare the sets relationship based on the difference, set difference. X minus y. So use except. Except x except y. If it's equal to empty, then x is a subset of y. Can be proper subset, can be equal to y. So this one means we have two cases: x equal to y, or x is a proper subset of y. Can only have these two cases. But anyway, x can not be larger than y. X is a subset of y. Okay, let's look at next one. We test for unique. This is simple. We just go with it roughly. So basically, we want to test whether a subquery has any duplicate tuples in its results. So that means if your subquery generates a table, whether the table has any duplicate tuples. So this one we construct event is to true if it is contain no duplicates. No duplicates means it's unique. For example, like this one, find all courses that were offered at most once in 2017. So that means we want to test this courses is not, we cannot have twice, because 17 we have multiple semesters, 2 semesters, and maybe 3 semesters. So we don't want this course appeared twice in this year, fall or spring. So here we just list each course how many tuples in this for this year. How many times. For example, we have one outer query we use course. In one we also involve the course, so we just use refer the name. This one is T. And then we because course offering, we use a section. With a section. From the section, we also give a new name as R. While the T, the course ID, we connect this one and the section based on the ID. So we need to establish the relationship. So that means we are now looking at the same course based on the course ID. We look at it one by one. This one will list all the courses from the courses table. And then for these courses, we use the ID to retrieve the section table. So how to retrieve? This course ID must be equal to this section course ID. Courses.course ID equal to the section.course ID. And at the same time must be the 2017 the course, that year's course. So R, this one, we're still looking at this section. Use one course ID to retrieve the section. R dot year must be 2017. So that means the same course and offered in this year. How many tuples you can obtain you can obtain. If you got more than one, that means we are not list that one, means this is false. Okay, unique means you got only one. Okay, only one. And also cannot be nothing. Okay, if it's nothing, this one is also false. So it will be true if it contains no duplicates. Okay, unique. That means there's one, only one. Okay, that's what we call it unique. So this one will list all the courses offered only one time in 2000 that are offered only one time in 2017. Okay. Okay, just now we talk about in the where we have subquery, and then let's look at the second case. So the subquery is in the from. Okay, so that means that we start from the end. Okay, where, from, and then select. Okay, so in the subquery from subquery, let's look at this case. So SQL also allows a subquery expression to be used in the from. As long as you generate a table, of course, we can use it here. Okay. For example, let's look at find the average instructors' salaries of those departments where the average salary is greater than 42,000. Okay. So this one we seems is have two layers information. So the first one is that those departments, okay, average salary is greater than 42K. This is one. Excuse me. Okay. This is one. And then second one, if this is just like the department information, that means we only have interest in those departments. Okay, their average salary must be larger than 42K. And then we will look at those departments instructors, and then we want to calculate their average salary. Okay, average salary. Of course, for each department, right? For each department, you will get an average salary, because this is the average instructor's salary of those departments. So that means first find a department, and then their average salary is more than 42K. But and also you need to list each department's average salary for those one. Okay? Of course, all the results must be larger than 42K. Okay. So for here, you can find out we first select department name and the average salary. This is all the things we want to have. Okay? But here you can find out we have a new name, average salary. So that means it must be coming from the next, okay? From here. Okay. In fact, we define the data. Define the view is like a view. Okay. We define view here. So this one define what view. We look at each department's average salary. Okay, so select department name and the average salary as average salary from instructor, and then group by department name. So for here, we already mentioned before when we talk about group by. Right? So each department we first grouped, and then we calculate the average salary based on this aggregated function, and then we rename this value as a new attribute name. Okay, and then where average salary larger than 42K. Okay, so that means next one, after we generated this one, that means for each department we have its this department, this average salary, right? And then we just only select those departments whose salary are larger than 42K. So that means this one will generate a table. Okay? The table has two attributes, department name and average salary. And then we will only keep those tuples whose average salary attribute value is larger than 42K. Okay. Okay, so that means we got that tuples selected, and then you want to calculate, you want to get the result is the name and average salary. So last one is you just output the department name and the average salary. For here, because we only retrieve one table, okay? So department name must be from the instructor, and average salary is what we want to have. So for each department already generated its average salary. This average salary is larger than 42K, then will be outputted. So it's average salary. Done. Got. So you can find out we put a subquery in the from, and it's like you generate a view, temporary table, and then based on this temporary table we do the query. Right? We first generate a table, and then we do the query. We only select those one which are interesting for us. Okay. So for here you can find out we don't use the halving clause. In the preferred we use the halving, right? Select from well and then halving, and then we need to calculate the average salary based on groups, right? Each group, first we grouped, and then we test each group whether the average salary is larger than 42K. If yes, we keep that group, otherwise we throw it away. Okay. And then we can find another way to write the buffer query. This one, in fact, is only do something which are minor. Okay? In fact, we do the same things, but we just use a rename a function, rename a table. Okay? We can rename a table or relation, or return a attribute. Okay? This is rename attribute. But we also can rename a table. For example, like this one, we calculated each department average salary, and then we rename this one as a new table called the department depth average table. It has two attributes, which is the department name and the average salary. So the new table, okay? And then from this new that means we first generate a view. Okay? Generate view. This view is defined here. Okay, defined here. And based on this one, we continue. Others are the same. Okay? Are the same. So in fact, for this one, if you want to, later we talk about if we want to add something more, we can refer to this new generated table name. Okay? Name. Okay, this is the first example when we have a subquery in the from. Okay. You can either rename a attribute or rename a table. Okay, rename table. Generated. This is the view. So a temporary relation table name for it. And then in fact, next one we want to mention about in the previous one I mentioned we may just refer to this one to do continued query. It's still together with this one, but it's related to, that means we can refer to this one for further calculation. So we use the with, okay, with clause. So this one we have provided a way of defining a temporary relation whose definition is available only to the query. So after query, that means it's as whole. This as whole is a query. After the query is done, for example here, and then this will be destroyed. That means this one is only the lifespan is only within this query. Okay. For example, let's do this one. Find all departments with the maximum budget. Okay. So we first one need to find the budget maximum. Okay, which one is the maximum? And the next query is that if you need to compare, okay, where is the maximum? Because you need to first find the maximum, and then you will compare whether this department is equal to that maximum. Maybe you have multiple departments. Okay? So this is the idea. you can find it here. We have a with clause in front. So this one we find the maximum. Okay, find the maximum value. So that means from the budget, from the department, we find from the budget column, we find the maximum, and then we give a new name to this view, this temporary relation. With that means we assign a new table name to it. So that will be called a max budget and then value. So that means for this one, of course, we know there's only one value, and this value's table name is called a max budget. Its attribute called a value. So later we can just refer to this max budget and the value. Okay, so this is the idea. So you can find out we don't add a comma or something. Means this is as a whole is one statement. Okay, one query is one query. Okay, within one query. Okay, and the next one is easy because you already found the maximum, and then you just need to compare whether a department's budget is equal to that maximum budget. If it's equal, we list that department, and then if it's multiple, you will need to list the multiple as well. So select the departmental name from department and max budget. So you can find that this is the relationship. So this one, we'll use this one directly. So they are equal, correct? The budget, the department budget is equal to the max budget dot value. Means this is equal to the maximum budget. Okay, maximum budget. So very straightforward. Okay? You first do calculate the maximum. Second one, you compare with the maximum to list all the results. Okay, what the results? So here we have complex queries using the with. The complicated thing is that we may have multiple queries within the with clause. So you can find here we use a comma to separate two queries, and this is the reason we call it complicated. Let's look at the question. Find all departments where the total salary, that means the department's total salary, is greater than the average of the total salary at all departments. So that means this one is one department's total salary. This one is that you average all the total salary of all the departments. That means for each department you got a total salary, and then you calculated the average total salary. Okay, if this one department total salary is larger than the average, you will output that department's name. Okay, find that department name. So let's look at first one. You can find out we need to do this one. You will compare with this one, calculate this one, the average of the total salary at all departments. But this one you must get the total salary. So anyway, we can first calculate total salary and then calculate its average, and then we compare each department total salary and the average. Okay. So let's look at the total. This one is calculate total. Okay, total, that means you want to group the departments according and then calculate the total salary for each department. So previously we calculated the average salary within a department. So here we calculated the total. Okay. So in fact we define the first table or view 1. Okay. View 1 here. This is view 2. So this one is for the total. This one is for the average. Okay. So this one is the total. Okay, total here. This one is the total average. So we define this name is the department name and the value. Means is which department, what's the total. Okay. You can also use the total here with the value. That means refer to this table's attribute. And this one, how to get this view? In fact, we just calculate the total. That's easy. Select from the instructor and then group by department name, and then you will just list all the department name and its total salary. as one row, okay, one tuple. So department name and the total salary. And then this one will be this one will be this one. Okay? The sum we give a new name called value. So this is total salary with respect to each department. And next one, we want to average these values. Okay, these total salaries for across all the departments. So how to average? You will select from here. Okay, this one. Then do the average from department total, and then we average all the values. Okay, so you need to get a value. Okay, get a value because you will compare with this scalar is only one value. Okay, so you will give a new name to this. Even is one value, you need to refer to this table. Okay, to this table. Later to this information table, you must refer to a table. So we give a new table name temporarily, just call it debt total average, means the total average total salary. Okay, so this one will be just make sure this total average total salary is not the average salary. Right? Average salary, that means you put all the instructions together, you do average. Here we just first calculate the total salaries for all the departments, and then we average across the departments. So it's divided by the number of departments, not divided by the number of instructors. Okay? So that is a difference. That's how difference is. So this one we just select average value, because based on this one there's only department name and the value. We only have interest on the average all the values across different departments. So we get only one value, give a new name for the table, department total average, and then value. And the next one is that we only need to list all the departments whose total salary, that means the total is larger than the average. So that means like total larger than average. Average is also about total. Okay? That's easy. So that means you will have this one total, and also the average. So you have these two. Just compare this based on these two tables. Okay? One is department total, the other one is department total average. From these two tables, you will list the department name. As long as the department name, department total value means the total is larger than the average of the total. Okay? So department total average value. Done. Okay? So this one though is complicated, but it's straightforward. And also the new thing is just like we put two, we can put multiple. Okay? We combine multiple views, use with. So if, for example, you have a very complicated query, you don't know how to write this one in one select from while clause, you may just you may be able to put them into several steps, like a procedure structure way. So multiple steps, and then how to put these things together, because if you write them into separate queries, you cannot refer to the previous queries table. If you generate a new result as a like a view, generate view, you cannot, if this is select one, another select, so you cannot refer to those results. Okay, how to refer to those results? You use with. You may list several temporary results after with clause, so put them, and then later you use you may select from while query to refer to the previous generated views, and then use those temporary results to generate your own result. So this one is something like a very important if you, in the future you are joining a company, you are working on database which maybe handle a lot of queries like this that maybe need a bit complicated. So make it easy for you. You can do like this way. This is really like you have a function 1 and then function 2, and then your last one is based on the function cat. It's the function of f1 f2. So you first generate the functions and then call it in your function, like you use this function calls. Similar idea. Okay. Okay, last one is easy. Also, this is the last case. We already talked from the end, where or from, and then this one is select. So we call the scalar subquery just because we put a subquery in the select. If it generates a scalar value, we can put it into the select. There's no problem, correct? Because select means we mentioned it before. You can use select value fo like this one. So a constant or scalar, there's no problem. No problem. Okay. So this is one which is used where a single value is expected. For example, like list all departments along with the number of instructors in each department. We can generate like this way. Of course, you don't need to do like this. You may use others, but this one we can do like this way, because we know we want to list all the department names, and also there are the first one is name. So list all department means the name, because that's the primary key, and then also the number of instructors. So we know we have this structure at least. Select from the department. We want list the department name. And next one will be the number. The number. How to get a number? We perform, because one department can only have one number. Number of instructors. So we perform a query which can generate only one value. So how to generate this one? That's easy. You can count how many instructors in the instructor table. And also the connection is just you must only count those instructors which are belonging to this department. So where department dot department name. So that means from here, the department name equal to the instructor department name. That means this instructor belongs to the department we are query for this one. We want to output this department how many instructors. So we fix the department name each time, and then we do like this way. So we can give a new name to this one, because this one is a scalar. You can have the adds number instructors, means this value we assign new name to it to be num instructors. Okay. If we have returned more than one result tuple, is not a scalar, then it will return error. Okay. So that means here so far we have covered all the three cases about the nested subquery from while, from, and select. Okay. So last section is very simple. Let's go over it quickly. So this one is all of the things we mentioned here is DML. So next one we'll talk about DDL. That means we want to update. Okay. We want to not completely DML. I think. Anyway, this one, all over the previous one is about the query. It's about query. So we don't change them. And this one is that we use update, delete, and so on, like this thing. Let's look at the user insert. So modification. So this last one is about modification of the database. This is used very often as well. We can delete tuples. We can insert a new tuple or a set of new tuples. So in fact, we can do that one as well, just like in a batch mode. That means insert multiple tuples. We may not just insert one by one. If we want to perform something, for example, you can prepare data into a text file or CSV, and then you can insert multiple tuples based on a loop, and then updating. So delete, update, insert. Let's look at one by one. The first one is that we want to use talking about deletion. We have different things about deletion. What's the means of deletion? So if you want to delete data, we use deletion. If you want to delete a table, we use drop. Okay? So here we talk about the data. For example, you want to delete all instructors, so delete from. So many students will just don't add something in between. In fact, delete from is a whole as a keyword for this one. There's nothing in front. Delete in between. Delete or start from. Do not confuse with select from. So delete from is just from a table. Okay? You cannot delete what from something. It's not like select from well. Okay, there's nothing in between. And then this one means we want to empty the table. We still keep the table, but I want to empty all the contents of the table. Okay? Delete from instructor. And next one is delete all instructors from the finance department. So here we add a condition. It's not all departments. We only delete the finance department's instructors. Okay, delete from still the table, but get a condition. The department name is equal to finance. And next one, delete all tuples in the instructor relation for those instructors associated with the department located in the Watson building. Okay, first one, all tuple in the instructor relationship in this table. And then for this instructor relationship, we can find its department. Okay? From department table, we can find its building. So here we only just, for example, this building, all the department located in this building will be just deleting all their instructors. Okay? So delete from still the instructor table, and then the department name is in this set. So that means we find all the departments whose this one there's a missing underscore. Select a department name from department where building equal to Watson. All the departments which has a department building in the Watson. Okay, and then select. That means if any department belongs to this list to be deleted. So it belongs to this list, then we'll delete the instructors. Okay, delete instructors. That means they delete all the instructors belonging to a department which has a building in the Watson. And the next one, delete all instructors whose salary is less than the average salary of instructors. Okay, so here it seems like we want to compare with the average salary, and then we just, if it's less than this one, then those instructors will be deleted. So in fact, we can do like this one. We first delete from instructor, of course, the same, and then the instructor's salary is less than this value. So this value we'll do like another query, select average salary from the instructor. This is easy because we want to find the average salary of all the instructors. So in fact, when we do this one, we have to load what's the running procedure. Because for example, if we delete one by one, and then if we delete one instructor's tuple, then the average salary is changing. Okay? So that's why in fact we are not doing that way. We first do this, and then we do this one. Okay. So we first compute the average, and then we find the label all the tuples to delete, and after that delete the tuples. Right? So that means that we are not recomputing the average every time when we delete a tuple. Okay. So you will do like this way. This will avoid confusions, kind of ambiguations. And next one, we also use insert. Insert is used very often as well. For example, like you create ER diagram and get tables. So you need to populate data. So how to populate data? This one gives an example. Use insert into a table and then values the table values the tuple name tuple values. Of course, you can list the attributes after. For example, like this one, insert into course ID, title, department name, credit, and then list them. If you change, this one does not matter because it will just do the correspondence. Which one will be assigned, which value. Okay, if you don't do, that means you need to list all the values here. Right? If you only want to assign values for some attributes, for some others maybe using none, then you need to list those attributes in front, and then later we are just corresponding. Right? Otherwise, we don't know how to do the assignment. And then last one is add a new tuple to student with total credit set to none. Okay, add a new tuple to students with, that means if the total credit is none, then we add a record for those students. Okay, so that means insert student values is this ID and the name, department, and the total credit set to non-value. Of course, you can just only list the three. For example, like this, I mentioned the name, the ID, name, and the department, and then you get rid of this one. Then the default value will be the none. Okay, non-value means not a no. Currently, we haven't decided. Okay. Let's look at the insertion again. For example, make each student in the music department who has earned more than 144 credit hours as a make them an instructor in the music department with a salary 18k. Okay. So first one, this means student. Okay, this is student. We want to add the student record into the instructor table, okay, as a teacher, as an instructor. So there's a condition. They must earn a credit which is larger than 144. And then after that, we insert the student's information to the music department. And then the salary will just initialize to be 80k. So we need to know instructor and the student, they have different relation definitions. Okay? So we need to differentiate. Make sure we insert the values in the records accordingly. First one, we need to insert into the instructor. This is no problem. Okay? And how to insert the instructor? We use a batch mode. So here we don't use the insert into table and then values, list the values. We want to do a retrieval from the student table. If it meets some condition, we insert that record into the instructor table automatically. So we have the select from and while. So that's the table you want to generate, and after that you will insert to the instructor table. Okay? Instructor table, we know we have ID and name, department name. Okay? This is required. And then the salary we mentioned, we just set a fixed salary 18k. Okay, 18k. And then query we are from the student. So ID, we know the ID is the same as this one. So name will be student name. And then department name is also student okay. So here we are assigned to be music department. Okay? So this ID, name, and department name. So here, of course, you can use the music, but here we we have this one, then that's also fine, correct? Why we need to do this one? Because we cannot put this one, but you can put this one here because it's equal to music. But anyway, we still need to test the department name because we don't want to add any other department's student, correct? Only the music. So the department name must be equal to music. So when we query the student table, and also their credit, correct? Their credit must be larger than 144. Okay, excellent students. So total credit have achieved. And then maybe instructor, that means maybe for those students will receive a TA and then assign them. The salary is 18K. Okay, this is the basic idea. Department name equal to music, and then total credit equal larger than this one. So this one is the student department is music, and also the student's total credit is larger than 144. And after that, you insert a record into the instructor table, the ID, student name, and also the department name will be music. So, and then the salary will be 18K. Okay. So for here, we evaluate this one first. Otherwise, we may have trouble. Correct? We mentioned similar like previous. You will do this one. You will first find the query, find the result you want to insert, and then we'll do this one. Otherwise, you will not you will query like this one. Insert into table 1, select also from the same table. You might have a problem. Correct? Select then, so you keep inserting. Correct? Insert select from table 1, and then you find out something, and then so will cause troubles. Okay, so this one there's no problem because we evaluated this one first, and this one is not the same table as this one. Okay, we mean copy from one to the other table. Okay, this is the insertion. Let's look at the next one is for update. So we can delete, insert, and update. Okay, update, we use update and set well. Update set well is just like the clause. Okay, it's clause. For example, we want to give a 5% salary raise to all instructors. So we do like this way. That's easy. Okay? Update instructor, and then they have salary information in the instructor table. Set, you set salary equal to salary multiplied by 1.05. We mentioned before we can use simple arithmetic operations. Okay, and the next one, give a 5% salary raise to those instructors who earn less than 70K. Okay, 70K. So we look at only those instructors whose salary is less than this one, not all the instructors. Okay? So update instructors set salary equal to this one. Well, we add a well. So the difference is just like this. Okay? Well, the salary is less than 70K. So over here, we first identify all the tuples need to be updated, and then we increase the salary. We will not do again and again. Cut. Again. Next one, give a 5% raise to instructors whose salary is less than average. Okay, similar thing. We need to calculate average, and then we identify all those instructors which require update, and then we update finally. So it's like this one. I update same instructor, set salary this one, and then the instructor salary is less than the average. Select average salary from instructor. So that means we find the average, but we calculate this one first, and then we use this one as a constant. Check each one by one. Okay, we will not do it like just calculate the average multiple times. Okay, next one. Increase the salaries of instructor whose salary is over 100K by 3% and all others by 5%. Okay, so here we need to care about the thing. So in fact, it seems like we are doing two groups update. One is 3%, the other 5%. and the condition is whether the salary is larger than 100k. So we need to do this one in a correct way, correct? So then how you will update the salary? So in fact, you may have two groups, two steps. Maybe you will just update the 5% first, and then update you at the 3%, or vice versa, correct? 3% first and 5%. Whether the order doesn't matter. So let's look at the example like this one. There are two updates. Each one is doing 1, correct? This is 3%. This is 5%. If salary is larger than 100k, we add 3%. This one is next. If it's less than 100k, we do the 5%. So you can find that we first do those instructors whose salary is larger than 100k, and then increase 3%. So of course, after you add 3%, it's still larger than 100k. And then we're looking at the rest. Okay? Rest will be the instructor whose salary is less than 100k, less or equal. Okay? Less or equal. So the second query you can find with semicolon. That means this is one query, this is another. Okay, another, not the same. So update instructor set salary is 5%. So when we look at this one, in fact, there's no problem because this one is you didn't update. Okay, didn't update. It will not be more than 100k. It's still the same value. We didn't change it. Okay, we didn't change it. For here, we only care about the 100k above. So here is about only 100k is below. When we update this one, there's no change to this group. Okay, there's no problem. Okay, for this one, seems okay. Okay, if it's 99k, and then we will be there, and this one will be increased 3%. This one will be 5%. There's no problem. Okay, we just like a scan individually these two groups. So we don't want to have a mess up. What's the meaning? For example, if we reverse the order, what will be the problem? We first do this one, because this one we can switch, because it's one independent clause, another independent one. If we do this one first, update instructor set salary larger than equal to salary multiplied by 1.05, where salary is less or equal to 100k. And then we do this one. The problem is what? If we increase this one, okay, give you 10 seconds, 15 seconds to consider. Okay, if this one is doing like this way, we first increase those instructors whose salary is less than 100k by 5%, then it can be more than 100%, okay? 100%. If it's more than 100%, and then we do the query again, so this one also holds, okay? Then it will be increased by 3% again. Okay? This is the problem. The order doesn't matter. So for this case, it's not good to remember because maybe it will be easy to make a mistake, the order. So it's better we use another way which can avoid mistakes. Okay, we use a case. So we use it this way. Update set case when then. You can list multiple when then. So it's case and end is a pair, and then inside you have this when then is one case, okay? And then you have another when then, and then the last one is else. So that means we update the instruct table. We only scan one time. Salary equal to case. When the salary is less or equal to 100k, we increase by multiplied by 1.05. Otherwise, because there's only two cases, if you have more cases, you have another when, then there's no comma or something. This is only one clause. Okay, and then last one is the else multiplied by the 3%. Okay, so this is the idea. So for this one, there's no confusion, okay? Because you only scan one time. If it's less than 100K, increase by 5%. If it's else, that means it will be 3%. Okay, let's look at another one. Updates with scalar subqueries. Okay. For example, we want to recompute and update the total credit value for all students. For example, after release the scores, and then each student will receive the credit. As long as the credit is not a fail, then it have a credit 4, 3, 2, 1, for example, like this. So we just update. That means we want to recalculate the total credit, do a database consistent update. So how to do this one? Okay. So in fact, for this one, we do like this one: update the table. Update the table, student table. The student table will have the total credit for this attribute. Set the total credit to a value. This value will return a scalar value, only one value. That's why we assign this total credit to be a value. So what will be the total? What will be the total credit? So it will be the scalar subquery here. Within this update set query, there's another subquery. So you can find out we do like this way. We want to calculate total, so select from takes and courses. Just because you must join these two, you get the credits. Takes will get a credit, and the course will just decide the and the text course ID equal to the course ID. So the reason we want to join these two tables is just because we want to get the credits. So text, we don't have that information. Text is only like the grades, semester, course ID, and the student ID, and so on. So we want to get the course credits. How many credits? So we need to use this one. Okay, like this one. So that means the course ID of the text equal to the course ID of the course. And then the student ID must be the text. This is having the relationship. This we are looking at the student. So student ID equal to the course the ID. And then also the grades, we have requirements. Grades cannot be fail. Cannot be fail. And also the cannot be null. Null means we have not taken that course. Have not taken, don't know. We don't maybe haven't assigned the credit, or haven't just like not assigned. Credit not assigned. For example, maybe there's some other credit like I means it's pending, like these things. Okay, so F and is not null. Okay, these two things. So this one is fail. This one is unknown. As long as not this case, and then the student take this course, so the course ID equal to the course ID. So then you can find the credits and then sum them together. This means all the credit hours for that students. Okay. So next one is set total credit to null for students who have not taken any course. For example, if some students have just started, have not taken any course, So instead of we use this select sum, this clause, select sum from where, we can replace this all of them, use this one. So that means that we update the student S and total credit to equal to the case what? Case when sum when sum credit is not null, then it will be the sum credits, otherwise will be 0. So that means if this one is not an unknown, then we just assign these real values, otherwise we assign 0. Okay, so it seems like this is much easier than the previous one, correct? So that means whether this one is not a null or not, so we can get a value here, get a result here, true or false. If it's true, then we just assign the sum credits, otherwise we assign just 0. Okay, this one, that means we can use this or this. Okay, but this one anyway, we have different things. This one we can assign total credit to null if not taking this one. This one with that, like we only care about those students who have taken some courses. Okay, this one is further do the rest. Okay, we can combine these two queries together. Okay, that's all for these slides. We finished the initial, that means basic SQL, and then you already can do many of the things we want to do in the course project, and then the rest will be the easier one, just like we were looking at chapter 5.1 for the JDBC, ODBC, and a little bit of introduction. I think maybe we have used up all the time. I will confirm if it's we used all the time. We may just see you next week. We'll start with the database design. I already released the slides, and then we'll continue with the design, and then you can start your course project. Okay, you can also listen to waiting for my further announcement regarding to the group formation. Okay, that's all for this chapter. Okay, thank you.